name is Mitchell Bowles, and I'm the project manager for Team Pointe. We are a group of 4 engineers in our final semester of our capstone design experience. We're actually going to be developing a product that we are calling CIGCOM. CIGCOM stands for Critical Independent Gas Compressor Monitoring. And our package and project is actually going to include a processor. It's going to include a few other things. I'm going to go ahead and give a brief overview of what those things include. Also, I wanted to mention that we're working with a company called Intersys Corp, who is a gas and oil measurement and automation systems company. They provide that type of service for other people. So I would like to first start out and show you what we're actually going to be using so that we can also monitor a natural gas compressor. And I want to start out with the SCADAPAK 350, which is a processor with a 32-bit architecture, and that's actually what we're going to be programming on. It has quite a few inputs and outputs that are digital and analog both, and then we also have RS-232s, RS-485, and then USB and Ethernet as well. So we'll be able to communicate through those ports. I would also like to mention that we're going to be making our own expansion board, and this expansion board is going to be able to decode an RTD signal, because we're actually going to be having temperature inputs that we're going to have to send through an ADAC and use those signals to create information that will be useful. Now we're also going to be able to add input modules, specifically analog inputs, on our expansion board so that we can have multiple sensor inputs. All these sensors will be inputting a 4 to 20 milliamp signal, and we'll have to convert those to real numbers in our software conversion. Finally, I'd like to mention that we're going to be using Bluetooth to communicate with field engineers who can pull up to the site where the gas compressor is, and they will actually have to physically be there, but they can actually pull up all the sensor data to make sure that everything is running correctly. Now, one of the key things to our project in using this expansion board, where we're also going to be using another processor that we're going to pick, we're going to be using this data that we're trending to look at what is happening over time for the compressor. This will be able to alert field engineers so that they might be able to come out and fix something if it ever goes wrong, or when it's about to go wrong, saving them time and money, and therefore creating a higher rate of efficiency for the system. I think that about wraps it up for CIGCOM for now, and we hope to be updating more as the semester continues. Thanks.